Good morning, dear students. My name is Radheshyam and we are going to discuss how error combine in different algebraic equations. So first of all, we are going to discuss how error combine in case of addition. So now let's say that a quantity Z is dependent on two physical quantities A and B by an addition relation, and let's say that we have measured A and there is an error in A, so we'll write it like this: A plus minus error in A. Similarly, we have find out that there is error in B, and so we report B like this: B plus minus delta B. And when we add this, so we get the quantity Z, and that should be Z plus minus delta Z, and this should be equal to A plus minus delta A plus B plus minus delta B. So we can see that A plus B is delta, A plus B is Z. So we see that plus minus delta Z is, or error in Z is, plus minus delta A plus minus delta B. So whenever we are trying to find out, so error in Z will be delta Z. So whenever we are trying to find out error, we always report the maximum value. So we'll not see this as plus, and we'll not see combination of this, or plus. We can take sometimes plus, sometimes minus. We will not see it like that. Whenever we are calculating error, we always report the maximum error that is possible, and maximum error that is possible is delta A plus delta B. This is the rule, that we always report the maximum error in a relationship. We always report this. This is the rule. So whenever you are in doubt that there are sign plus minus signs, so always take plus sign, add them. I mean, simply take the maximum value of that. So in case of addition, the two physical quantity A and B's, so in their error gets add up. So this is the relationship. So in case of addition, error are simply added up. So now we'll see what will happen in case of subtraction. Let's say that we have a physical quantity Z that is dependent on A and B by this relation A minus B. A is subtracted from B. We know that the error in A is delta A, and error in case of B is delta B. So we report the quantity like this: A plus minus A, B plus minus delta B. So we'll write this like z plus minus delta z is equal to a plus minus delta a minus b plus minus delta b. So we'll write it like this: a minus b, a minus b is z, so z this will cancel out, z plus minus delta z, and then we'll write it like this: delta a minus plus minus delta b. We'll write it like this. So we are saying that the error in z will be, we see that this is the quantity that we want to calculate. What this is the error part. So what did I tell you? I told you that whenever we are asked about error, we always report the maximum error. So we will take both sign to be same. So in this case the error will be, maximum error will be plus delta b plus a, delta a plus delta b. That will be the maximum error in case of subtraction also. So it doesn't matter whether it is the two quantities are added up or subtracted. When we are trying to find out error, then their errors always add up. This is the result, that it doesn't matter whether the quantities are added or subtracted. Whenever we are trying to calculate error, we always add those individual errors. This is the result. And then after that we'll try to calculate what will be the error in case of product and then we'll try to find out what is the error in case of quotient, or you can say what is the error in case of division. So first we will see what is the error in case of product. So let's say that our quantity z is defined like this: a into b, and we know that the physical quantity is reported like this: a plus minus delta a, and b is reported like this: b plus minus delta b. And the error that will happen in z will report it like this: z plus minus delta z. So we'll write it here: z plus minus delta z, and we'll write a plus minus delta a multiplied by b plus minus delta b. So we'll see that this is ab and plus minus b delta a plus minus delta b, a delta b plus minus delta a delta b. We know that delta a and delta b are very small quantity. That's why their multiplication will be extremely small, and that's why this is considered 0, or we neglect it compared to the other terms. So this quantity is neglected. So we will write it like this: z plus minus delta z is equal to this. Okay, so now we want to find out what is the relative error, so we'll divide by z both side. So we can write this like 1 plus minus delta z by z and equal to AB by z will be 1 plus minus, this will become delta A by A plus minus, this will become delta B by B. So we can write a relative error in Z will be like this, delta Z by Z, and this should be written it like delta A by A plus minus delta B by B. So what is the maximum relative error that can occur? So we'll take the sign to be same, and that's why the maximum error or maximum relative error in Z will be delta A by A plus delta B by B. So in case of product, we say that the maximum relative error in Z or maximum relative error in product is equal to summation of relative error in A, relative error of A plus relative error of B. That will be the product of, that will be the relative error of the product. So hopefully this makes sense. Okay, so we'll now try to see in case of quotient how. So let's say that our Z is defined by A by B. So we'll write it. We know that error in A is A plus delta A, or measured quantity is, our measured quantity A is reported like this: A plus minus delta A, B plus minus delta B. And we know that the error in Z, so Z will be reported like Z plus minus delta Z. So we'll write it like this: Z plus minus delta Z, and this should be written like A plus minus delta A divided by B plus minus delta B. So let's say we are taking A from the numerator, and from the denominator we are taking B common. So this will become 1 plus minus delta A by A, and this will become 1 plus minus delta B by B. Okay, so this will become, so we now we say that we are dividing both side by Z. So we'll get 1 plus delta Z by Z, and A and B divided by Z will be 1. So we'll get this quantity 1 plus minus delta A by A, and we'll get this 1 plus minus delta B by B per raised power minus A minus 1. And since delta B by B is very small quantity, what we'll do that We'll write it like this: 1 plus minus delta A by A into 1 minus, we take minus inside. This is essentially what we are doing. We are taking a binomial expansion of this 1 to power x, and that becomes 1 plus nx in case of when x is very less than 1. When x is small compared to 1, then we do the binomial expansion like this. So we can write it. So minus 1 is taken inside, so plus minus become minus plus. So now we multiply and solve it. So we'll get delta z by z, and we'll get plus minus delta A by A and minus plus delta B by B, and 1 will cancel out, and the product of this quantity is 0. Delta A by A into delta B by B. This is exceptionally small quantity because already delta A and B are very small. So delta A by A and delta B by B is very small, so we'll neglect it. So we get delta Z by Z is equal to this quantity. So relative error, maximum relative error again will be delta A by A. Will take plus sign. We want to report the maximum error. So we see that in case of product as well as quotient, in case of product as well as division, the relative error in the product is equal to relative error of sum of relative error of either quantities. So it doesn't matter whether it is product or quotient or division, relative error or the maximum error that happen in product and quotient is always sum of either quantities of relative error, or you say sum of relative error of either quantities. This is right. So it doesn't matter whether it is division or subtraction, division or quotient. Similarly, we have seen that in case of summation and subtraction, we have seen that the maximum error is always sum of both quantities. Similarly, we are saying that in case of product and quotient, that relative error is sum of relative error of either quantities. So the next kind of quantity, physical quantity that we often encounter is a power raised. So let's say that a power raised to the any physical quantity, power raised. So let's say that we have a physical quantity Z and a physical quantity A, but A is now A square. So Z have a relationship with a physical quantity A by A square. So now we want to see how error combined in case of power raised to the given physical quantity. So we say that measured physical quantity is reported like this: an error in A. So we just have calculated that error in case of product is always error in case of product. So we say that A and this A are different quantities. So we have just calculated that error in this case, a relative error in this case will be relative error in A plus a relative error in A. We have just calculated. So we see that in case of power raised, that power comes in front, or you can say the power is multiplied. So the relative error in Z now becomes 2 times relative error of A. So you can understand that if there is a power n, so the power come n times relative error of A. So whenever there is a power raised, so the relative error will come power times relative error of A, or relative error of the given physical quantity. So now we want to calculate the most general case. So let's say that Z is dependent on a physical quantity A raised to power P and a physical quantity B raised to power C and divided by C to the power R. So now we want to calculate what will be the relative error in case of most general case. This is the most general case in product rule. So what we will say that we know that the measure quantity A is reported like this, B is reported like this, and C is reported like this. And we know that error in Z will be reported like this. So we have just calculated. So the relative error in Z will be, what we are saying, we always calculate maximum of the relative error. So P, and this will become relative error of A plus Q relative error of B. And we know that because this is division, so we know that there will come a minus sign, but we always report positive, or we always report maximum error. So this will become R into relative error in C. So this is the relative error in case of general product equation. So hopefully this makes sense. If you have any doubt in any step, you can always raise your question.